because we've done this before, I'm going to be posting this on YouTube and sending out links to you and everything else. I don't have, you guys are going to be in Canvas for what, all of like 8 more hours, or something. So I won't put it in Canvas. I'll just send it out to you in an email, the link to this YouTube video. So anyhow, we're going to start out with a box. Boxes are fun. You're like, no, they're not. Okay. I'm making the worst box on earth here. Try again. Okay. And we're going to say that our gold standard up here, not God standard, gold standard. Gold standard can have 2 results. The gold standard can either be positive for disease or negative for disease. Because we said our test has 2 results, right? So we're just going to divide our box into positive and negative, right? Now, we want to check our gold standard. Okay, so now we're setting it up. We're going to check our gold standard to our new test that we've developed, okay? Our any other test. So we're going to call that any other test. We're going to call it an ultrasound. Okay. And with our ultrasound, we're going to have 2 results, right? This is pretty simple. What are those results? Yeah, it can either be positive or negative. If you get a question like this and you have to draw the box, please draw it with the pluses and minuses exactly where I'm showing you. I'll show you in a minute why that's important. Okay? And it has to do with Sesame Street. You think I'm crazy? No, I'm not. Okay, so what we end up with is we end up with this comparison. We have our gold standard that's positive or negative, our new exam that's positive or negative. If they both agree and the test is positive, we're going to call that the true positive. Okay, they both agree. This is the true positive. If they both agree and the test is negative, we're going to say that's the true negative. Okay? That goes in the bottom right. Okay? Okay. If our test says it's positive, but the gold standard says, it ain't real, then that's a false positive. We said it was positive, but it's wrong. It's a false positive. So you'll notice that on your box there, everything in the top row of the comparison part says positive, right? That makes it easy. And it's true positive when it matches with the gold standard. Well, guess what? In the bottom part, if we say it's negative, but the gold standard found that it was positive, that's going to be a false negative, okay? That's really bad, by the way. We have missed the disease. That's what that means. That's a false negative. Okay, everything in the bottom is negative. Where it matches with the gold standard, that's a true negative, so the other box has to be the false negative. Okay? Keeping it as simple as we can. So now our box should look something like that, right? True positive, false negative, true negative. All right? All right, so let's look at our definitions here. True positive is when we match the gold standard and the disease is present. True negative is when we match the gold standard and there's no disease present. Those are the easy ones. All right? Everyone agree that's easy? Okay. Let me know when this gets hard. false positive is when our test said it was positive, but the gold standard said, no, no disease present. That's a false positive. That's an okay outcome. If I scan you and I miss the fact that you have cancer and you go get a CT and they find it, we found the disease. It's okay, right? That's okay. Let's see. Yeah. No, wait a minute. Let's see. So false positive, yeah. If I scan you and I found that you had cancer, but the gold standard said you don't, that's okay because you don't have cancer. Right? That's good. Now, a false negative is the bad one. That's the one where I scan you, you actually have cancer, and I don't find it. That's bad outcome because it may get missed until it's too late. Okay? So false negative is the bad outcome. Anyhow, our test is incorrect. It's false because it didn't match the gold standard, and the patient actually had disease. All right.
So which one's done first? The gold standard or?
No, this is generally, in Realityville, doctors order ultrasounds. And we tell them whether the patient has disease or not. If the patient continues to have symptoms, they might go back and have a CT done later. You know, if they don't have symptoms, they might go home. Who knows? Okay? So there is no order to how these are done. Usually when we're doing this, we look at our data, we call this positive, we call that negative, we call this positive, and then we go back and we see, did these patients have other exams? So somebody sits in a room and does this. They look, did the patient have other exams? If they did have other exams, they correlate and they say, okay, this is the gold standard, what did our other exam find? And they go back and they do a statistical analysis and you do an aggregate. How accurate were your exams? There's no order to how these are done. You don't actually do them in the correct order. Okay, this is just an aggregate, a statistical aggregate of what's going on nationwide, you might say. All right, so let's compare our exams here. Let's see, we've got, if we go down this column here, we go, this is the number of patients with disease, right? If you do a study and you start checking out all the patients that the gold standard said had disease, all the patients our new test said had disease and did, this is the patients with disease. This is called the true positive plus the false negative. Okay, so for our exam, that's what this is. So if we go back to our box and we draw a line down like this, this is going to be the true positive plus the false negative, okay? And that's all the patients with the disease, right? That's all of them. Mm-hmm. Because the gold standard said that's all of them, all right? If we go back and we look at our results and we look at this second column, this is the true negative plus the false positive. And that's all the patients without disease, right? Mm-hmm. Okay. Now we're going to give a couple of terms to these in a minute here. But let's first start out sensitivity. This is our ability to detect disease. So with our test, we want to know how sensitive it is compared to the gold standard. This is the number we're going to come up with. We're going to say, how good was our test at detecting disease? And we're going to define that as the sensitivity. Okay? And we want to be able to detect a very small prevalence of disease if it's present. Okay? Now I'll give you an example of a really stupid test that can detect disease. All right? Everybody raise your hand. I'll just wait till everyone's hands up. Okay, there we go. Everyone whose hands up has the flu. Right? I guarantee you, if you have the flu, that test just found it. Right? It did, didn't it? The stupid test, I told you that to begin with, right? What's the problem with that test? It does detect disease. It doesn't detect if there's an absence of disease, right? We need something more specific, so that's our specificity. Our ability to determine if a disease is absent is the specificity. All right? Now, I don't have a quick flu check in here that's specific. Okay? I know I can find 100% of the people with flu, but I can't separate out the ones that are healthy. I haven't come up with that test yet. We'll work on it. So we're going to define something here. We're going to say that our true positives, if we go back to our table there, our true positive divided by our true positive plus false negative is our sensitivity. And our true negative divided by our true negative plus false positive is our specificity. So let me see if I can make this happen. Okay, so this is the let me rewrite it down at the bottom. Okay, so our true positive, and see, I'm just taking everything in this column and rewriting it. This blue column that I have here is my sensitivity column. And it is the true positive over the true positive plus the false negative. And then, you know, you multiply that by 100% to get it in a percentage, but whatever. And then my specificity is this green column here. And so that is the true negative over the true negative plus false positive. And that equals the specificity. Okay? Now, I'm going to make these equations really, really simple for you. When you're dealing with these columns or with anything else we're going to do today, here's the equation I want you to remember. True over everything. Okay? True over everything. So if you're dealing with that column that is blue, the sensitivity column, you put the true over everything else in the column. Boy, that was easy, right? And that's your sensitivity. And you go to the next column and you go, okay, true negative over everything else in the column. That's your specificity. And here's why I wanted you to draw the box with the pluses and minuses exactly where they are, is that way your sensitivity and specificity are in alphabetical order from left to right. That's the Sesame Street part. It's in alphabetical order, okay? Easy. Easy peasy. So how do you get your specificity? You take your test, you compare it to the gold standard, you fill in the boxes, And then you know exactly what box is what because you can tell that because all the positives are up in the top row, all the negatives are in the bottom row. The true matches the gold standard and the false is everything else, right? You've got that. So that's how you find your sensitivity and specificity. And we do it this way, and it's alphabetical order, and we have sensitivity and specificity. All right, so let's do an example. Examples are fun, right? Yeah, right. Okay, so here's a way to avoid breast biopsies. Now, I will tell you that the breast biopsy is the gold standard for determining if a patient has breast cancer, right? If they have a lump, you do a biopsy, right? Well, they used elastography. This was from 2007. And they looked at 123 patients with elastography, and they found 18 breast tumors, okay, with the elastography. They did not, comparing it to the gold standard, they did not miss any cancers, okay? That's good. They compared it to the gold standard and found that of the tumors that they found, of those 18, 17 really were cancerous tumors, okay? So let's see how we set up this box, okay? Let's do this now. I almost need to do this. I want to leave this information up here, so I don't want to switch over to the to this thing. So I'm going to draw it out on both the board and on here so you can see how we fill in the boxes. Go ahead and turn up the lights for me if you would. And we'll go on the board and we'll do this up there. So the first thing we want to do is make our box. First thing we want to do is erase our board. All right, let's make our box and figure out where we're going to put our stuff. Okay, does that look like our box? Okay, good. And what's up here? Gold standard. And over here is our elastography. Now, we had a total of 123 patients. We don't know yet where to put all of them, but we're going to figure that out. All right. 18 tumors were identified with elastography. So where does the 18 go? Elastography found 18. So these two boxes had a total of 18, right? We're good on that? All right. 17 were confirmed. Confirmed means compared to the gold standard and found. So in here, we've got a 17. These two boxes have to equal 18. So what goes here? 1. 1, right. Okay. No cancers were missed. Okay. So gold standard, we didn't miss any, so this would be a 0. All right? So what number goes in here? 123 minus 18. Yeah, 123 minus 18. These are patients without disease, and we didn't miss any, right? So what? How many is that? That's what? 105. 105? Okay. So that's our box. Let's go ahead and label it, because we're smart people and we can do that. This is the, what's this box? True positive. It was positive for disease. It matched the gold standard, so true positive. This one is the
False true.
this bottom right. True negative, right? Remember, negatives are all on the bottom, so it has to be negative. It matched the gold standard, so it's the true negative. Okay, so we know that this will be positive, this will be negative, and we know that it's not true, so it must be false positive, false negative. Okay, so that's our box. All right. Now that we have that, we can go back to our drawing. All right. So I'm going to quickly fill out this box. We go 17 here. We got 1 there. We got 0 here. And we got 105. So do you guys see how I got that information out of that statement that they gave me? Okay, and this is true positive. This is false negative. This is false positive. And this is false negative. Or true negative. Whoop, true negative. Okay, so we've got our boxes. All right, so now then, what is the sensitivity? All right?
Ability to detect if disease is present.
Right. That's the definition, the ability to detect if disease is present. And in our elastography example, so we're going to do this. We're going to do the sensitivity. So, yeah. All right. All right, so we're going to take this column. And remember, I told you, true over everything, right? So 17 over 17 plus 0, that's our sensitivity. Okay? Who can do the math for me? 100%, right? Great, good. All right, let's do our specificity, our ability to exclude disease. Not going to be quite 100, right? Okay, and this is going to be true, which is 105, over everything. Yeah, that formula works. Okay, what is everything? It's 105 plus 1, right? And that's our specificity. Alphabetical order, S-E-N, S-P-E. Okay, so this is going to be about 99%. You guys can do the math. I don't know exactly what it is. Huh? Yeah. Okay. So that's the specificity, all right? True over everything. It's a real easy calculation to do. Okay. Now let's think about our test. When our test says it's positive, how often are we correct? Well, that's called the positive predictive value, okay? And so here's the really cool thing about this table. If you look at the table, if I'm saying something is positive, look at this. I have a whole row here that's filled with positivity, right? My positive predictive value is going to be this row. What's the formula? True over everything, all right? So when I go to calculate my positive predictive value, all right, I'm just going to go into this row here. And I'm going to take it, and that's the row. It's going to be positive predictive value. And it's true over everything. So what's true in that row? 17 over 17 plus 1. And that's going to be what? 94%, okay. So my positive predictive value was, come on, little thing. Having some trouble here. Hello. %. Isn't that cool? True over everything. It works. Well, what's the other thing we're going to have to find out? Positive predictive value and, yeah, going to have to come up with the negative predictive value. Okay, negative predictive value is when we say it's negative, how often are we correct? And so we'll go with this row here. We're going to say that's the negative predictive value. And what is the equation for that? True over everything. So what's true? The true is 105 over everything in that row, which is 105 plus 0, which equals 100%. Even I can do that math. Okay.
What is this called? The false negative predictive?
Well,
Predictive value.
Negative predictive value?
it's called the negative predictive value, yeah. The false negative is the bottom left corner, okay? So this is the negative predictive value. When we say it's negative, how often are we right? Well, in this test, we were right 100% of the time, which was nice. Whoops, this is carotid. It should say breast. So there's another term that we want to know. I'm going to change that right now. Breast elastography. There we go. So what is the accuracy of this test? Okay, so we've done a sensitivity was this column. Specificity was this column. Positive predictive value was the top row. Negative predictive value is the bottom row. Anyone want to guess what the accuracy is? All of them. Yeah, I heard somebody say all of them. The accuracy is all of them. So the accuracy is all of them. So what's the formula for accuracy? Come on. You people. It's the same formula. True over everything. It's still the trues over everything. I told you, one formula here. One formula. True over everything. All right? So our true in this case, we have true positive, true negative. That's 17 plus 105. Okay, so let's put up accuracy here. 17 plus 105 over everything. Well, I already know what everything is. It's 123. Got it. Even I can put that number in. Okay, and so it turns out to be 17 plus 105 is 122 over 123. It's greater than 99%. Okay? Really good accuracy on this particular elastography. So this was 2007. I guarantee you elastography's gotten better since then, but they've also done more tests, and they're finding it's not quite 99%, but it's pretty good. Okay. So accuracy is true over everything. Again, one formula. I'm trying to keep this easy for you. Okay? One formula, true over everything. All right, so we throw in some numbers. So we have this. What is the specificity we came up with on this? It was 99%, or sensitivity was 100%. Specificity was 99%. Positive predictive value we found was 94%. Negative predictive value was, let's see here. Yeah, 100%. And our accuracy in this case was 122 over 123. So I'm going to skip a few pictures here. So what was that? We got that. Okay. So let me now give you the cheats. That's how you do this, okay? Now, here's how you cheat at it. And cheating's legal, okay? Your accuracy. Okay, let's write sensitivity here. Specificity. And negative predictive value. Your accuracy will always be between your sensitivity and your specificity. They give you a multiple choice question, they give you sensitivity and specificity, guess what? The accuracy is going to be the answer in between them. So it's in between them. Always. Guess what? If they give you the positive predictive value and the negative predictive value, the accuracy is going to be between them. It's always going to be between them. So if they give you these two, you can always determine that the accuracy, that usually gets you down to at least a 50-50. Okay? 99% of the time on the SPI exam, it gets you the answer. Okay? It's always between them. If they give you all four of these, accuracy is going to be between all four of them. It'll fit in there somewhere. It'll fit in there. Accuracy is always between these. Yeah.
On the SPI, is there a way, like once you're done with the question, you can't go back to it?
Yeah, you can mark it and go back
And
to
go
it.
back
Yeah.
to it.
So if you get one of these, here's what you do. Mark it and move on. What? You're giving away cookies? No. You mark it, you move on. This might take you more time to do than any other question on the exam. So you mark it, you move on. You get to the end and you answer everything else. You go, oh gosh, I still have 20 minutes left. I can either go out to my car and be done, or I can work on this for about 5 minutes. And it's not that hard. You draw some columns, all right? You put sensitivity and specificity in there in alphabetical order. The stuff with positive, you know, is going to be the positive predictive value. The stuff with negatives is going to be the negative predictive value. The only equation you got to remember is you put the true over everything in each column or row, or everything if it's accuracy. And if they give you this or this, you know the accuracy is in the middle. So if it takes you 5 minutes to do it, I'm ashamed. What's the hardest part about this whole process?
Figuring out what you need.
Where do you put the numbers? Okay, read the question carefully and figure out where to put the numbers. That's the hardest part of the whole darn thing. They'll give you an example, and You have to figure out where it goes. So I started out, it said 123 patients. I wrote that down in the corner because it's got to add up to that. 18 were identified with elastography for our test. 18 were identified as positive. That goes over here. Then you got to figure out how to break it out. That's okay. You can do that. Take your time. You're already done with the rest of the test. You're just trying to get that one more cookie. Okay? Yeah.
So on the question, is it going to have like percentages that we have to actually find the percentage, or?
If it is percentages, it will be very easy math. 100. You add it up, it comes out to 25. What's 25 out of 100? 25%. It will be easy math if they do that. Again, they don't let you have a calculator, so you can't do math that's going to take long. This is not a math test they're giving you. They don't care if you know how to do long division. So it's going to be easy numbers.
So what's going to be like an example of the question as far as like question and answers? Like,
So a realistic example of a question would be ultrasound was done to find carotid stenosis in patients that had the gold standard of an angiogram to compare it to. The positive predictive value was found to be 54%. The negative predictive value was found to be 72%. What was the accuracy of the ultrasound? And it'll give you 4 choices. One of them will fall between 54 and 72. That's really the kind of questions they tend to ask. That's the kind. But they might ask you something, the true positive numbers were 75, the false positive were, true positive were 100, false positive was 50 or something like that. What was the positive predictive value? So they will tend to break it out. Once in a while you get one like this where you have to draw the whole box. Okay, once in a while. It's not very often. And the numbers work out pretty darned easy. And usually, even if they give you the whole box to try to figure out, if they do that, then usually you can still look at this thing and figure out that the accuracy is going to be between all those numbers. That's normally how it works. At the end, you spend 5 minutes, you can't figure it out, you lost the cookie, okay? This is not a 555 question. This is one of those that, when you're trying to go between 600 and 700, right? But the fact is, if you've been struggling through the test, spend some time on it, You might just get a cookie, all right? That's sensitivity and specificity. Was it hard? Did we do? Okay, I know it took a long time. Okay, I'm not going to just try to throw it out there. Sure, the Cliff Notes is, accuracy falls between everything. But yeah, I still have to explain it. Okay? If you get stuck and you get something where you have to find the sensitivity, you can do it now. But was it hard? No. There's only one equation. True over everything. Whatever you're dealing with, true over whatever that is. That's the equation. See? It's just as easy as doing decimal conversion. And half of you are like, yeah, that wasn't really easy either. That's okay. All right, let's take a break until 11. And then we'll come back and get started on Doppler, right? What is 11? Yeah, we'll take a break till 11, I think. Because
So my senior was telling me that there's a thing called persistence. I don't know, there's like 5 or 6 questions on the SPI test that were persistent. I don't remember ever coming across that word.
frame averaging,
Yeah,
that's it.
yeah. So
Did we
is there
not?
anything else about that? Because I Google searched it and it said it was about frame averaging, but I don't know anything more about it.
So, what does it do? Reduces noise, can slow down your temporal resolution.
Okay.
It can reduce speckle. Speckle is noise.
Okay.
Those are the main points. They're, you know,
Okay.
what is it? It's frame averaging.
Okay.
I can't think of anything else they would ask you about it.
Okay.
But if they said there are 5 questions, that's a lot of questions on this system.
Yeah, she's like, yeah, they had like 5 or 6 questions. She's like, I have never even heard of that word. I didn't know what it was.
I mean, there's color persistence.
Yeah.
That's where you take the color flow over time and you just keep observing it
Okay.
over time and adding color frames together. But again, persistence reduces your temporal resolution, and it so it reduces temporal resolution. It smooths out the image. It does a lot of things, but those are the main points. Is that slows things down, reduces temporal reduces noise.
Okay. So it just kind of clears everything up and it just slows
Yeah.
down the frame rate. and everything
Yeah.
else. Okay.
Yeah.
Alrighty. Thank you.
But like, she's right, like, my mom doesn't play my daughter.
Did we not cover that yesterday?
Not her birthday.
I've never heard that ever like in the class. I think we probably talked about it with it just being a
We
different
probably
word.
called it frame averaging.
Yeah. So that makes sense when you're saying it. I was like, well, that's
Yeah.
probably done. It's just another